Great. So we will go over today's assignments or today's classwork. So that was so you had to create 4 offices, the same thing we did, or I did on the screen last week. And now you have to work with the template I provided you with, the Revit template, and then you have to create that space. I didn't give you a lot of information because I want you to create different buildings. And these are the list of materials, but I didn't give you any thickness or width of materials because you have to create a roof or a wall that meet this passive house standard with R value above 80 or R value above 50. Okay, so you have to use these materials, but the thickness or the width of the material is up to you. So, okay, Zach, you have submitted the classwork. Do you mind if I open?
You can open it, yeah.
Okay. Well, I was going to do it anyway, but if you don't mind, it's better. Okay, so let's open this file, and I'll show you. Well, first I'll go over. Okay, this is Zach's classwork, and we have a load report. There should be 2 reports, 1 and 2. Okay. Then on level 1, we have the 4 offices and this lobby space. We have walls on the 3D view. Okay, so there are windows, large windows on the south elevation, small windows in the north elevation. We have a roof with layers, and we have a wall. Okay. So first, I need to click on the wall, and if I edit type, I need to see. Okay, so the thermal resistance is 61. It should be above 50, so that's fine. I can see the layers. And well, I didn't mention, but the thickest layer, well, here we have the structure. So it's a concrete masonry unit. You selected a foot for concrete masonry unit. If we click on this concrete masonry unit, CMU thickness. Okay, so these are commercial thickness, so I cannot ask for, okay, I want a concrete masonry unit with 4 inches and 4.5 inches. It doesn't make any sense. So we have these commercial blocks, and it's 4, 6, 8, 10, or 12 inches. The width, the height is always 8, and the length, it's either 16 or 8. Okay, so we have a block or half a block. So that's it. Okay, so this is the width, which is 16 inches. The height is usually 8. We can have only half block, so it will be like a square, 8 by 8. And then the width, the dimension that we don't see, it can be either 4, 6, 8, or 12. Okay, so Zach, you have decided foot, so it's 12 inches. That's fine. What about the roof? If we click on the roof, I have to go to edit type. The roof is 80, the thermal resistance is 80. Good. And what about layers? Okay, this is what I wanted to see. As you remember, we had for the roof, where's the roof? This one. Okay, so this is the roof. We had a false ceiling, an air gap, concrete slab, rigid insulation, and this external finish. This is the waterproof layer, so we have to protect everything against rain because this is a flat roof. Okay, so we need this membrane, this EPDM, and this is for water protection. But we had the chance to create the false ceiling and the air gap. False ceiling, it's a gypsum element. I assume that you all know what a false ceiling is, but false ceiling detail. Okay, this is a false ceiling. So we have like a structure, like a grid made of aluminum or stainless steel, And then we have a gypsum board here. Okay, so when we don't want to see the mechanical systems, the ducts or the pipes or whatever, we just hide everything. We have an air gap, and then we hide this in a false ceiling. So the section, yeah, so that's the idea. We have the structural element here, and we hang this false ceiling. What is this gap? It depends on the size of the things that we are going to. So if we have air ducts, you know that air ducts are quite thick, so we have to increase this the air gap. Or if we have only water pipes, a water pipe can be 1 inch or 2 inch or 2 inches. So this can be 3, 4 inches. That would be enough. But if we are running air ducts here, we might need 8, 10, 12 inches or even more. It depends on the size of the things that we are going to include here. Okay, but this is the false ceiling. So there are two ways to do this. We can either do it here in the detail, but it's better because I showed you how to work with false ceilings here. So in section 1, yeah. So it's better if we do this with the Revit false ceiling option. Okay, so here we have the false ceiling and here we have the air gap. And the roof is just this element. So we have the concrete slab, the thermal insulation, and then the waterproof membrane here at the top of the roof. Okay. Can we do this? Yeah, so we can insert here, if we edit type, I'm not duplicating it because then I'm going to delete it. So I can include another layer. I can insert down, and this can be air, and I can type here air, and this, let's say that it's a 4 inch. And finally I can insert, go down, and I can type here finish and gypsum, say 1 inch. Okay, then apply, and then I click OK. And now I've got this. So you see that I have the air gap and I have a false ceiling here. I think if you want to create a false ceiling, this is a better option. Okay, so we can undo, and we can have this floor just with the concrete, the structural element, the thermal insulation, and then the waterproofing. And if we want an air gap in the false ceiling, we can use the ceiling option of Revit. I showed you how to do this last week. Okay, but don't do it twice. Okay, so it doesn't make any sense that you have this false ceiling here and then you include the air gap and the gypsum board on the roof element. So make sure that we have, I prefer this option actually. Okay, so you can do this. And now we have the first load report and the second. So as I told you, the second load report should be better than the first one. So the first one, if we analyze the peak cooling loads, it's 123. The peak heating load is 70. On the second load report, it's 155. Okay, so that makes sense. But Zach, can you tell me what you did to improve the performance? What did you do?
I changed, so the windows, I analyzed them with the normal 8, and then I changed all the windows to triple glazing 0.65.
Okay, so if I see the window thermal load, so these are
Both
the
of them
window.
different.
Yeah, they should be different. So this is the cooling is 67, the heating is 25 on loads report 1. And if I go down here, okay, it's 45 and 9. Yeah, so that makes sense. So you just change the kind of window, but the rest of the walls, the doors, it was the same?
All the doors and walls were same, yeah.
Okay, the roofs. I mean, we don't have here. You see that we have doors, and the load is 0. You do have doors, as far as I know, but those are internal doors. Okay, so if the temperature in this space is the same as the temperature in that space, there is no heat flow through these two spaces. And as you don't have any door, okay, so it's a doorless building. Yeah, you don't have any door. Well, you don't have any door because I didn't write external doors, but well, in a real building, we should have an entry to the building. Anyway. Okay, so that's it. So that's correct. We need to load reports. I need to see that there are 4 different spaces. If I go to the section, the office space has to, we have a false ceiling here. We don't have a false ceiling on that space. So this is correct. Okay, that now we are going to improve this. Okay, so we are going to work with this. Maybe it's not relevant when it comes to the load report, but we need to make sure that this is a good detail, because now we have this, and what we see is that we have a huge thermal breach here. Okay, because if we have heat here, if the heat tries to go this way, we have thermal insulation. If it goes through the roof, we have thermal insulation. But if the heat goes that way, we don't have any thermal insulation. We only have the concrete slab here, and we don't have any thermal insulation in this path. Unfortunately, even if we work this out, Revit won't change the load report. Okay, so this is a limitation when it comes to this energy analysis in Revit. Revit is not meant to be an energy analysis software. It goes well, and that's good, because if we change something, we can see we are doing something good or bad just by analyzing the overall heating and cooling loads. Okay, we can do that. And even we can understand the percentage. Okay, so if we change the window, if this is 67 and this is 45, the windows, okay, so we can see the percentage. If we change the wall, so this is 352 and now this is 352 because you haven't changed anything on the walls. But look at this, you can place much more thermal insulation on that wall. And how much can you reduce the cooling load? From 300 to 200, 100. But here, just by changing the window, we have changed from 45,000, from 67,000 to 45,000. Okay, so the amount of energy that we can save by changing the window is much more than the amount of energy that we can save just by adding more thermal insulation to the wall. Okay, so there is a moment in which, when we meet the passive house standards in walls and roofs, that's it. Yeah, we can add, instead of 8 inches, we can have 16 inches or 20 or 50 inches. And probably we reduce this from 300 to 200. Okay, that's fine. But if we analyze this, we have 67 and 300. So first, we need to solve this, because we have 67,000 here and we have only 300 here. Okay, so the issue is in the window, it's not in the wall. So that's it. Even if we analyze the roof, okay, the roof is 35,000. Why? Because we have a huge area of roof, and we know that the heat, especially in the heating loads, well, let's look at the heating load. So this is 36, and this is 36 as well. Okay. Well, that's interesting, because by looking at this, when it comes to heating loads, even with in loads report 1, with a single glazing or whatever, we are losing less heat through the window than through the roof. Okay, so we are losing 36,000 here and 25,000 here. Okay, so I think there's room for improvement when it comes to the roof. It's an 80 R value, Yeah, but I think it makes sense. Here, when we have a good window, the percentage of the roof heating load, it's even bigger, more significant, because here we only have 9,000 and here we have 36,000. Okay, so this is what we have to analyze. If we look at this, can we do anything about the walls? Looking at the first report. Okay, so on the first report, if we're analyzing cooling loads, we don't have cooling loads through the wall. We have 67,000 through the window, and we have 35,000 through the roof when it comes to the cooling load. If we analyze the heating load, we have 1,000 through the wall, 25 through the window, and 36 through the roof. Okay, so first, cooling loads are more significant than heating loads. And we are in a cold area. By default, we are in Boston. I don't think you changed the location. Okay, the project location by default is in Boston. Okay, it's a cold place. So even though we're in Boston, what we have to understand here is that cooling loads are more important than heating loads. Why? Well, probably because we have a bad design. Okay, so it doesn't make any sense. In New England, the heating loads should be always higher than the cooling loads. If that happens, it's because we have a bad design. We haven't protected the windows against the summer sun. So we have done something wrong when it comes to the design. But this is something that we have to realize, okay? So we have 100 for cooling loads and 55 for heating loads. Doesn't make any sense. Second, what are we are losing energy through the walls, through the windows, and through the roofs. Okay, what is the worst part? The window. It's always the worst. In cooling, the window is terrible. In heating, it's not that bad because we have used triple glazing. Okay, that's fine. But the next thing we have to change is the roof. Okay, so probably I would add more thermal insulation on the roof. It's fine. So 80 R80, it's a good value. It meets the passive house standards. But can we make it better? Yes, we can. Okay. But if I had to make a decision, I would try to change the cooling load for windows, because the cooling load and the heating load for roofs, it's the same. So it's 35 and 36. But the cooling load for windows is 45, and the heating loads for windows, it's 9,000. So I think, yeah, so this is the biggest issue that I'm finding here in this building. Okay. So we have to analyze this by looking at the data. It's overwhelming because we have a lot of information here, but we need to know where to look at. And we have this is the building summary. So here we find out that cooling loads are more important than heating loads. And then we have to go element by element. Usually we have walls, windows, and roofs. Okay, so let's analyze walls, windows, and roofs, the cooling and the heating loads, and then we try to draw some conclusions. Okay, so this is how it works. But now I told you that we want to fix this detail. Okay, so I'm going to do this 3 times today. So first, I will draw it by hand. Second, I will fix it with using Revit. And finally, we will use THERM to analyze this detail. Okay, so if you are able to do that, if you are able to understand what the good detail is, and you are able to draw it, perfect. Then if you are using Revit, you should be able to fix that in Revit and create a good detail in Revit. And finally, Revit doesn't analyze this from the energy point of view. So that's why we need THERM. Okay, so we are using three ways to describe the same. Okay, so let me grab my and there you go. Okay. So what are we going to do now? We are going to draw a detail that works. Okay, so I'll start from scratch here, and I'll start drawing that detail. So we know that we need a concrete. The structural element is a concrete masonry unit wall. Okay, so this is the concrete masonry unit wall. We know that we have a structural slab here. So we have a concrete slab here. So this is concrete. And yeah, but this is not correct, because we have if this is a roof, we always need like a parapet here. Okay, so we can have a flat roof, but we need a parapet. We need to prevent people from falling down. So that's why we need a parapet. Okay, so this is the main structure of the building. But now, again, I'm going to talk about materials. So I'm going to use concrete here. Okay. This is the concrete wall, and this is the concrete masonry unit. So let's create the concrete masonry unit here. Okay, so this is a concrete masonry unit. And now we have to apply the thermal insulation material. So the thermal insulation material, it works well when we wrap all this detail with thermal insulation. Okay, so if we have this orange material or this yellowish material, we have to wrap all this with thermal insulation. Even the parapet, for sure, we have to increase the thermal insulation in the roof, because the roof is looking at the loads report, we need the thickest thermal insulation here, and then we need thermal insulation inside the wall. I will do that. Okay, so let's do this, and then we will talk about thickness. The problem is that we have to protect the thermal insulation material because we cannot have thermal insulation indoors and outdoors. So we have to protect this material. How can we do that? The external finish can be, let's say, brick. Okay, so as it was stated in the classwork, we need brick here. Okay, we have a brick layer, and we needed we needed a gypsum board wall or a gypsum board finish here. Okay, and then we had a false ceiling. If you remember, we had this false ceiling here, and the false ceiling is hanging somehow from this. And here we can have air ducts or pipes or whatever. Okay, so this is air, this is the false ceiling. Okay, so this is the brick. This is the brick wall. This is the air gap. This is the thermal insulation. So we can always make this hatch for the thermal insulation. Okay. And finally, we need to protect this. We need a cap here, because if it rains, okay, if it rains, the rain has to go out and has to go out this way. Okay, so I think this is a detail, and this is what we have to do. So you know that we have the concrete masonry unit. We need the, if this is a bearing wall, if the concrete masonry unit is the structural element, we need to rest the slab on the concrete masonry unit here. Why? Okay, so we need this on the concrete masonry unit, and then we need the parapet. So we continue the concrete masonry unit on the, yeah, so we have to continue the concrete masonry unit here. And then we need to wrap this with thermal insulation. And then we have to protect this, because if we didn't have this cap or this coping element, the rain could go through this and could damage the thermal insulation material. Okay, so this is it. And this is inside. And this is outside. Okay, so if we have heat here, if there's a source of heat inside, would be usually warm. This is winter, so the temperature in winter would be 70 Fahrenheit, and the temperature outdoor, I think it was 8 Fahrenheit. By default in Boston, it was 8. Okay, so the heat tends to go out, and we have to make sure that we always find thermal insulation. So if the heat tends to go through the wall, we have thermal insulation here, and then we have a second layer of thermal insulation here. So this is protected. If it tends to go up, we find thermal insulation here. But what if it goes this way? So we also have thermal insulation here. So here we have prevented this thermal breach from happening, okay? Because we do have thermal insulation in that phase of the slab. So that's a good detail. Okay, so we find thermal insulation. So I want to go out. So even here, I find another thermal insulation at the top of this parapet. So remember, try to draw an arrow, and if you find the thermal insulation in any direction you try, that's a good detail. If you find a way in which you don't have thermal insulation, that's a problem. Okay, so this is the hand drawing detail. Now we have to do the same with Revit. Okay, so here we have a window. That would be more difficult. So we are going to try this detail without windows, okay? Because here we will find out how to fix this, or how to solve this detail, the transition between a wall and a window, because it's complicated. But now we are going to try to fix this. So if you have taken CAD3, well, CAD3, ARCH320 with me, you should be familiar with this. If you haven't, I'll show you how to do it. Okay, so with Revit, this is the wall, and this is the roof. And as you can see, if we select the roof, we cannot select individually this layer or that layer or that layer. So everything is it's the same object in Revit, and it's the roof with 3 different layers. But here we can always create parts. Okay, so you go to this menu and we create parts. We have a video here, and this is what we're going to do. So we create parts, and now we have individual elements. We can either select the, this is the slab, this is the thermal insulation, and this is the membrane. And we have to do the same with the wall. So we have to create parts. Before doing this, if you don't mind, Zach, I'm going to do something that I think it will improve the detail. You remember the walls, so there's something that we can fix here. Okay, so let's select the wall, edit type. Okay, you didn't do this. I told you that the structural element should be within the core boundary layers. Okay, so let's do this. So let's move all these up. Let's move it down. Okay, so I'll move the brick up, then the air layer up, the rigid insulation up, and then I'll move the finish down and the thermal air layer down. Okay, so the structural element, the concrete masonry unit, is within this core boundary. It's better. It's not relevant when it comes to the energy, but it's relevant when it comes to the detail itself. So let's click OK and apply. Okay. And now in the plan, if we select this level of details, we should be able to move this to this axis. Well, make sure that when you are doing this with the wall, with our Revit wall, well, it doesn't work today, but the midline of this concrete masonry unit wall should be matching with this axis here. Okay, so I don't know why it's not working today, but anyway, get used to doing this. So get used to select the wall and make the structural element here within the core boundary. It will work. It will work better. Okay, but anyway. So let's continue with this. Anyway, this is the concrete masonry unit. No, let's create part first. Okay, so when we create part and we select this, we understand where we are. So this is materially the cellulose. So this is thermal insulation, and the thickness is 7 inches. Okay, if we select this material is the concrete masonry unit, and the thickness or the width is 1 foot. Okay, so now we know this. So what is the first thing we have to do? We have to move this because we need to extend this thermal insulation to wrap all this, and we have to create a parapet. Okay, so there are a lot of things we have to do here. So first, let's select this, and if we want to change the dimension of this material, we have to show shape handles here. Okay, so if we go to the properties windows and we show these shape handles, then we can move this here. This is the concrete masonry unit. This is the the concrete slab. And now we can extend, if we show shape handles, we can extend this up to this point. But now this is the thermal insulation, the roof thermal insulation. So we need to show shape handles, and then we need to move it here, okay? No, because we are going to extend the concrete masonry units to make the parapet. So we have to, this is the thermal insulation, and we have to leave this open for extending this wall. And this is the waterproof membrane. So we can move it here. And this is the brick. Okay, if we select this is brick, 4 inches, show handles, and then we can move it up somewhere. Okay, so now we have to place the parapet. And I wouldn't extend this up because we cannot go through the slab. So this is the bearing wall. The slab rests on the bearing wall. And then as of here, we need to go up again with another masonry unit, concrete masonry unit. Okay, so let's do it. But I think if we create a new level, it would be better. So if we place that level here. And let's name levels. Okay, if you don't mind, I'm going to change your level names. So this is not level 3, let's call this level 10. This is level 12. And this is level 13. Okay, so now we have to go to level 13, and on level 13, we have to build that wall. I will put here. We have to build a new wall as of this level, just 3 feet, because a parapet is a 3 feet tall wall, so that we don't fall. Okay, so we can always insert a wall. We can go to view, plan views, floor plan, and I want to see level 13. Okay, so this is level 13. And now we have to place the parapet here. So let's create a new wall. We can start with this one. I'll edit type. I will duplicate. I will name it parapet. Okay, and I'll edit the layers. We have the concrete masonry unit. Here we don't have a finish, so I will get rid of this layer. And if we are outside, cellulose is not a good option. Cellulose, it's a good option when we are inside, because cellulose doesn't bear water. Okay, so if we are working with a parapet or a roof, I wouldn't use cellulose. There are different opinions about this, and I hope that you will have the chance to listen to different opinions. But in my opinion, we shouldn't use cellulose outside. So let's change this by rigid insulation. And do we need 7 feet? I don't think so. Let's say 3 feet, 3 inches, sorry. Do we need brick and air? No, we don't. So, and we don't even need the rigid insulation. So the wall is going to be made of just rigid insulation inside and concrete masonry units. And we can delete all these layers. We click OK. OK again. And now we have this parapet. And I'm going to place the parapet here. Okay. What have we done? Well, we have to change the height of this for sure. And top constraint. Let's make a new level. Say 4 feet. So that would be level 17. Okay. So now the top constraint is level 17. Well, much better. So now we go to section 1, and this is the parapet. So in this parapet, we have, do we need to create parts? Well, why not? So let's create parts. So this is the concrete masonry unit. This is the rigid insulation. So I'm going to pull this rigid insulation here. This one, I'm going to pull it here. And then, okay, so first, sorry. Before creating parts, you see that the wall is not aligned. Okay, so this is the parapet and this is the wall. So this and this should be aligned. So I can align this here. Okay, so that makes sense. So now we see that this is the concrete masonry unit and this is the concrete masonry unit. Now I can create parts and I can do the same thing again. Shape handles, go up. And this here. Am I happy with this? No, I think we can make it even better. So before creating parts, we have this wall because we need to wrap. I didn't draw this on the detail, but I think it's interesting if we yeah, there you go. So we do have the detail. We have to wrap this detail or this wall with thermal insulation, but we need a waterproof layer as well. So how can we do this? Okay, so we need to place something to protect the wall and the roof against water here. Okay, so this is this EPDM membrane. So this is water proof. We need this. Then we would need the vapor barrier. And I told you that this is controversial, but if I had to use a vapor barrier, I would use it here. Inside the thermal insulation and all the way up. Something like this. So this can be the vapor barrier. Okay. So vapor barriers are so thin that we cannot draw this in Revit. but the EPDM, so the thickness of this element, of this waterproof, can be an inch. Okay, so I think if we add this inch in the parapet detail, it will work. I think it will work better. Okay, so let's do it. And as you see, we can even add this EPDM layer on this face of the wall. Okay, so we can make this air gap narrower, and we can include this element here. Well, let's try. Okay, so we're working with this wall. This is the parapet. Let's edit type. So we can add, we have the structural element, the thermal air layer. So here we can insert something down. And this can be finish. And this can be the EPDM. Membrane. And the thickness is the same as the roof. It's 1 inch. Apply. Okay. So now you see that we have this element here. We have the EPDM layer here, and we have the EPDM layer there. And now we can create parts again. And we can show shape handles for all of them. And now we can do this. So we can go up to this place, then we can go up here. So now this can go this way and this way. And oh my God, this is not aligned. You have to align everything before creating parts, because otherwise it won't work. Okay, so you have to do this and that. So now this is perfectly aligned, and now we can create parts and show handles. Okay, so let's do it again. There. There you go. Do we need more here? No, because I can extend this. So I can extend this up, and I can extend this up again. Okay, so finally, I would need to wrap this with thermal insulation and EPDM layers. I'm going to do it in a different way, but first, I think it will be clearer if we select all the layers or all the parts. We override graphics in view, and we make everything invisible. All these patterns, they are invisible. We apply. Override the graphics in view, not visible, apply. Okay. And finally, we need this. Override graphics in view by element. Everything is that way. Okay. And now if we work with colors, I think it will be easier to understand. So first, this is the concrete masonry unit. Okay, so for the concrete masonry unit, I can use, I'm going to change the cut pattern, the background. Okay, so I will make it visible. Instead of by material, I would use a solid color and then I will use something grayish. Okay, so this is the concrete masonry unit. Then we have the rigid insulation. So this is rigid insulation. This is insulation. This is insulation. This is cellulose. Okay, I can have a different color for rigid insulation and cellulose. So let's make it different. The thermal insulation that we have outside and the thermal insulation that we have inside. Okay, so we can overwrite graphics in view. And with this background, I will make it visible. I will select a solid color and I will use a yellow. Well, and this is something that if we type red, green, and blue values that are easy to remember, it's 20, 22, 25 to 25 to 100. That would be better. Okay. And then for this, this is cellulose. So it's thermal insulation. So thermal insulation should be something grayish, yellowish, sorry, but with a different color. So I can make all these patterns not visible. The background is solid, and this by material, something like that. Okay, so that at least here we can understand what we are doing. Okay, so we have the concrete masonry unit, the slab. Let's change that material, solid. I will make it grayish, but a little darker. Okay, so we have the concrete masonry unit. This is the concrete masonry unit layer. This is the concrete slab resting on the bearing wall. And then here we have this element resting on the slab. Okay, so that's the right option. And then we have thermal insulation. The thickest thermal insulation is always on the roof. Here we have two different thermal insulations. Cellulose inside, because it's not affected by water. If it can be affected by water, I would place rigid insulation outside. And finally, this is the membrane, so we can make it override, and let's make it visible, solid fill, and let's make it something almost black. Okay, so we are wrapping this with this waterproof layer. Here we have the brick. Oh, I forgot the brick. Solid, and let's use okay, so nice. This is the brick, thermal insulation, concrete masonry unit, concrete slab, cellulose, and the gypsum wall can be white, so we don't need to change that color. Okay, so here, looking at this, we understand. We are not defining more, or we are not, so we just need this. Just to complete, we need to wrap, and I'm going to do this in a different way. So if we go to that level, I think I'm working on section 1. So this is section 1. I'm working here. And this is, okay, so this is a grid number 3. Okay, so in section 1, I'm going to use a model in place detail. Let's make it roof. And let's select extrusion, and then I have to pick a plane. So that's why I need to, I was in, at grid 3. Okay, and now I have to create this thermal insulation, this rigid insulation. It can be 2 inches. And then on the 3D view, I can extend this all the way and all the way here and all the way there. Finish model. And then on section 1, I just have to override in view by element. And now that's why it's good having something easy to remember. It was 225, 225, and 100. Apply. Okay, there you go. Yeah, then I need a cap to protect this against, so at least this, we have to protect the exposed thermal insulation. Okay, so here we are protecting this thermal insulation here using that brick. And how do we protect this? We have to use a cap. So I can just create a component, model in place. I can use, let's say, roof. And then I need to create a model line starting on grid 3. Oh. Let's finish model. And then, okay, this is it. I can always edit in place. I will use the inch 0.1, 0. .5. Okay. So this is a cap, and now I place roof. I will use extrusion. Set on grid 3. There you go. And now on this 3D view, yes, I can extend this way and this way. Model. Well, I didn't want to lose a lot of time doing this, but it took more than I expected. But that's fine. Okay, so I have all the layers I need here. I protect the thermal insulation with this black EPDM membrane. I protect the thermal insulation here with this cap, and I protect the thermal insulation here with the brick. Okay, and inside I have this gypsum wall protecting the cellulose inside. Okay, does it affect the? You should be able to do the same here. Okay, so. But now if we look at this on the 3D view, if you continue this all over the wall, even in section 2, with a fine detail. Yeah, this is the annoying thing about this kind of things. So that works only in section 1. In section 2, it doesn't work. So you have to do it again. Okay, so we have created the parapet. But everything that we have done in section 1 with layers and colors, it doesn't show up in section 2. It's a shame, but that's Revit. Okay. Anyway, if at least in section 1 it's well done, I think it's worth doing it. Okay, so we have done this with hand drawing, and now we have created the same detail using Revit. But if we don't know how it works, we cannot do that in Revit. Okay, so at least I don't know, in my generation, maybe we are old-fashioned, but we need to draw it by hand just to get to understand what we are doing. At least this is what happens to me. I don't know, maybe you are you belong to a different generation and you can start thinking with Revit directly. I can't do that, so I need to think by doing this by hand, and then when I have the hand drawing here, then I can do the same with Revit. Otherwise, it's tough to me. I mean, but it's up to you. If you can do this directly in Revit without the hand drawing, that's fine. Okay, and now I told you that we are going to do the same in THERM. Okay, because in THERM, we have to analyze, is this, no, we don't have a thermal breach, because here, if the heat tries to go this way, we have find the thermal insulation here. But now we can quantify how much heat we are losing through this, because this is a weakness, this is the weakest point of this detail, because the wall is well protected because we have 7 inches of cellulose here, and then 6 inches, so 13 in all, of thermal insulation. If I try to go this way, the roof, we have a foot in 1 inch, so it's 13 inches as well, of thermal insulation. But here, yeah, we have all this width of concrete, but we only have 6 inches of thermal insulation here. Okay, so this is the weakest point. We can quantify that. So how much heat we are losing through this thermal breach. It's not a thermal breach because it would be a thermal breach if we didn't have thermal insulation here. Okay, that would be the perfect thermal breach, because, but now we have thermal insulation, so it's not a thermal breach, but it's the weakest point. We have 13 inches of thermal insulation in the wall, 13 inches in the roof, but only 6 inches here. So how much does it affect the thermal performance of that detail? Revit doesn't calculate that. There are other software more advanced in terms of energy simulation that can evaluate the heat losses through this weakest point. But we are not going to study this in this course. We are going to use THERM. So THERM, it's a good software. It's for free, most important thing. And we can evaluate these details. Okay, if you go to the Canvas module that I have uploaded today. Okay, so on this module, I can add right away the classwork, THERM. Okay, I have a THERM template here. So I'm publishing this. So you can download this template, and then we can start using this. Why do you need a template? Because again, THERM by default doesn't have enough materials, or it doesn't have enough boundary conditions. So if we want to save some time, we use a template with all the materials and the boundary conditions that we need. And then we don't waste our time just creating all these things every time we open a THERM file. Okay. So
hey, Fernando.
Yeah.
The THERM file that you just uploaded, I went to open it and it gave me an error. This file does not have an app associated with it for performing this action. Like,
Yeah,
I downloaded THERM.
Yeah, because look at this. You want to see the same. Yeah. So it's well, it's in Spanish, but basically it's telling me the same. Because THERM, you have to be patient with THERM. It's for free. It's great. So there are a lot of guys working hard on THERM. So don't get angry. But it's not the best software on earth. Well, it is very good at simulating thermal breaches. Okay, so there is no better software than this. But the interface, you have to be patient. Okay, so the first thing you have to understand is that if you try to open THERM directly, you can't. So first, we need to type here. If you have THERM on your computer, THERM 7.6. Okay, so you have to click on this Windows and then open THERM.
I figured it out. Don't worry. You have to open it in THERM.
Oh, okay, open in THERM. But anyway, sometimes it would happen. Okay, so you have to open THERM first, and then you have to open the file from THERM. So I try sometimes, I have a THERM detail and I click on it, and THERM doesn't show up. Okay, so if it happens, you have to open THERM 7.6. I don't know, maybe in my computer, 7.7 version is not working. 7.6 it's fine. Okay, so and then we click File, Open, and now I select the template, and then I open the template. As you can see, on the template, we only have a rectangle with a material, foam rubber. But the most important thing is here, okay? So you see that if you click not in the material itself, but in this line here, in the border, you have wall HI int, and if you click here, you have wall HE X. Okay, so those are the boundary conditions. So I have included those boundary conditions so that you don't have to waste your time on doing this. Okay, so the first thing we can do is to delete everything. And first we have to view grid. So make sure that in view you have grid highlighted, and then this grid will show up. Again, I have created that grid. So in options, preferences, snap settings, we have show grid and snap to grid. Otherwise, it's impossible. Working with THERM without this snap to grid, and even without a grid, it's quite difficult. Okay, so make sure that these two things are on. But if you open that template, it will always be on. Okay, so with THERM, we can create details. We can create sections or plans, always working in 2D, 2 dimensions. We don't have a 3D detail as we have in Revit. Okay, so the good thing in Revit is that we can do that. And well, I'll show you how to do this in 3D. Now it's 2D, but we can do the same detail in 3D, in a 3D view. With THERM, we can't. Okay, so we have to work always with two different 2 dimensions, not in 3 dimensions. And okay, so I recommend you use that grid with 0.5 inches. And I recommend you, if you create view, no, if you click here, zoom, make it 100. No. Zoom, maybe 25. Yeah. Okay, so make sure that the zoom is 25%. Okay, it can be even less if it's 20. Okay, we see the grid, we see more dots because the grid is smaller. Okay, another thing we have to learn from THERM is that we need to start drawing here like in the middle of the screen, because if we start drawing here at the top of the corner, if we need more space, we cannot do that. Okay, so there is no zoom out in THERM. So we have to work with that zoom, but get used to working here in the middle. So you can select the zoom close to 20, and then you can start working here in the middle of the screen. Do not start working here close to the edge of the screen, because we cannot extend the screen upwards or leftwards or rightwards. So just, we don't know how big our detail is going to be. So just start drawing here. And we have limited options to draw. We have polygons and we have lines. Well, we have lines, the polygon, and we have rectangle. Let's use rectangles. And let's try to do the same thing we have done here in Revit, okay? So we have the concrete masonry unit here, and then we have the slab, and then we have concrete masonry unit going up, okay? What is the thickness? It was a foot. Okay. So if we open a rectangle, how can we draw a foot? 12 inches. If the grid is ½ inch, it's gonna be complicated. So let's make this 1 inch by 1 inch, the grid, okay? And now I think we can we select 12? Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is the concrete masonry unit wall. We select this, and now we have to change the material. Do we have something like concrete masonry unit? No, we don't, that I know of.
I saw concrete in that list. Would that be similar to concrete masonry units?
Concrete, yes. So the most similar. We don't have concrete masonry units. Now I was looking if we had any other masonry, whatever. No. So let's select concrete, this grayish thing. Then we have the slab. What is the thickness of the slab? So if we click here, it's a foot as well. Okay. So let's start this, and we have a foot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we go this way. And that would be, I think we can do, well, there's something we can do. If you click here, this select material, you can pick this material and then you can copy. Yeah, so you can do that. Okay, look at this. I did it wrong because now I cannot go up. Okay, so I warned you that if you do this, we cannot go up. Maybe we can change the zoom. Let's change it to 10. Yeah, we can change the zoom, but as you can see, if we have to include 12 inches here, it doesn't work. Okay, so let's do it again. And let's start with this here. So we need 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's gonna be my concrete masonry unit wall. Then I need another rectangle for the concrete slab. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. So this is concrete, okay? And now about the parapet, we need another 12 inches going up. Let's say this way. Okay, so we're done. Oh, can we move it? I recommend you delete it and do it again. So now it's 12 and up. Yep. So we're done with the concrete. What's next? We have the thermal insulation. So as far as I remember, that was 6 inches. That was 2, 3, and 13. Okay, so let's do it. So we can that was 6 inches. 1, 2, 3, 4, 5, 6. We go down. And now this is what kind of, do we have extruded polystyrene, polyester, polycarbonate, or do we have foam, insulation, fiberboard, mineral fiber? This could be glass wool. The fiberboard is the cellulose. Okay, so fiberboard, it's something similar to cellulose. We have this poly.
I'm pretty sure I saw extruded polystyrene.
So we have polyurethane. Maybe it's with the, okay, so here we have extruded polystyrene with CO2, with CFF, and well, all options with extruded polystyrene. We have either CO2 or CF or CFC, which is even more contaminant. Okay, so that's why this rigid insulation or extruded polystyrene, it's not an environmental friendly material. Anyway, so this is it. And now another rectangle, 2 inches here. There you go. So we can use this, click and click. Well, I'm pretty sure that everything I'm doing now, it won't work, but let's find out. Then we will have 1, 2, and 3 here. And then I think it was 13 inches. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, I know. It's okay. Let's do it that way. And here we had 7 inches, 3, 4, 5, 6, 7. And that wasn't a rigid insulation. That was the cellulose, foam glass, fiberglass. Where was it? Fiberboard. Do we have something by the, okay, we do have cellulose, fiber, cotton fiber, or cellulose, either one. So let's use cellulose here. Okay. And anything else? Yeah, we have the air gap and then the brick. Let's try this. Okay, so let's try this detail and let's see if it works. I don't think it will work, but we'll try. Are we done with this? No, we have selected we have the geometry. As you can see, we cannot do crazy things with the interface. We can just work with polygons or with rectangles. So we cannot do curves, or we can't. We can select a pretty good amount of materials. Okay, so I think the list of materials is quite good. But now it won't work if we don't select the right boundary conditions. Okay, so this is the most important thing to understand in THERM, the boundary conditions. So you see that we have here draw boundary conditions, this BC here. Okay. So we select this. And boundary conditions are these lines. Okay, so we can select not the material itself, but we can select the border. Okay. So this is a section. So we know that the section continues all this way and continues all this way down. And this is just the corner. So THERM is useful to analyze corners like this. But does it mean that we have to draw the whole section? So in Revit is by default, we have all this, but we are just analyzing this part, the intersection between the roof and the wall. So what does it mean? That we have the same material. So we are cutting the section here, but we are having the same detail, the same concrete slab, thermal insulation, and EPDM layer here. So that's why we have this boundary condition adiabatic. What is this? Okay. Let's look at Wikipedia. Adiabatic process which occurs without transferring heat or mass between the system. Okay, so this is it. There's a thermodynamic process which occurs without transferring heat or mass between the system and its surroundings. What does it mean? Well, if we analyze this detail, the heat transmission is from inside to outside, but the heat is not transmitted in this direction or in this direction. So it either goes up, it goes perpendicularly to the roof or to the wall, okay? But it doesn't go in this direction. Well, this is an assumption. Of course, there's some heat going in this direction, but for the sake of simplicity, we can, if we have this edge, we can understand that the heat is not going in this direction. So this is inside, this is outside. So the heat is going either this way or that way or that way, but it doesn't go horizontally. So that's why if in this cut line, we select always adiabatic, always. And this is the wall, so the same. So the thing that it's, we have to select a different option for this edge, the outside or the outdoor edge, and the indoor edge. Okay. So here we have walls and we have roofs. And if you remember, there was a different. So now I have to open the Excel file. Okay, so if you remember, we had this layer, interior air layer and exterior air layer, and we had a thermal resistance associated to that layer. Okay, so it was in walls, it was 0.625 inside, 0.34 outside, and in roofs it was slightly different. The 0.34 inside, no, outside it was the same, but inside it was different. It's different because we know that heat tends to go up. Okay, so we have to do this in THERM as well. So we have to select if this is a wall, because this is a vertical line, we have to change this boundary condition. So it's not adiabatic anymore. It's a roof HE, because we are outside. Okay, so that's why I have done this. So I have included roof exterior, roof interior, and wall exterior and wall interior. Okay, so here, this is wall, sorry, the vertical one is wall exterior. So you see that this is a red line. This tiny line here, well, it can be considered a wall exterior. If we have a horizontal one, we should select roof exterior. So this is roof. And what about this? Is this a wall or is this a roof? Well, it doesn't matter. So let's make it roof. Okay, so all this red line is exterior. If it's horizontal, I would select roof. If it's vertical, I would select wall. Okay, but now we have the interior boundary conditions. So this is a wall for sure. So I have to select wall int. And this is a roof. So I would select roof int. And all these cut lines are adiabatic because we don't consider that heat is moving in this direction. Okay, so heat is either going from interior to exterior. It doesn't go horizontally that way. Okay, are we done? I don't think so. Because if we click here, now we have to select libraries, and we have a boundary condition library. Okay, so that's interesting. If we have this wall EX, we are assuming that the outdoor temperature is 0 Fahrenheit. I can change that, so I can type here 8 Fahrenheit. I'm not going to do it, okay? But here I can select the outdoor conditions. So the relative humidity is 50%, and the outdoor temperature is 0 Fahrenheit. Okay, that's fine. If I go to library, I can go to set boundary condition. Okay, and here I have to click something different. This is wall exterior, but this is the U factor surface. Okay, so I have to change this as well. And again, I have included here, if this is exterior, in this U factor surface, I have to select exterior as well. But I have to do this on every single in library, set boundary condition, U factor, exterior, okay? This library, select boundary condition, U factor, exterior. Can I select all these? Library, set boundary condition, exterior, okay? Apparently I can do that. If I select this library, set boundary, okay, so we have exterior here. And then I can do the same with the interior boundary conditions. I select this line and this line, library, set boundary condition. By default, we have none, so I have to select interior. Okay. I think now we are ready to run this detail. But I know, I bet that there will be like a failure in the calculation process. So let's click calculation, and let's click calculation again. Oh, so it worked. Isn't it amazing? Yes, it is amazing. Okay, so here we have the temperatures. Okay, so inside the temperature, I think it was set at 70 Fahrenheit, and outside it was at 0 Fahrenheit. Okay, so the indoor surface temperature is 67, almost 68, very close to 70, and this one is very close to 0. And this is the temperature that we have in different layers. As you can see, when we have the wall or we have the roof, the temperature profile is parallel. So that means that this is what we do with this kind of Excel, with this Excel file. Okay, with this Excel file, we are calculating the temperature profile when we don't have corners. But if we have corners, we need THERM. Does it work? Does it help? I mean, the indoor temperature profile. It helps, but I think it's even better if we work with display options. And then we work with flux vectors. That would be interesting. We click OK. Okay. And now with the flux vectors, the size of these arrows is means that the way in which we are losing more heat. Okay, so we are losing less heat here than here. So the arrow is longer here. Okay, so here with these flux vectors, okay, so the heat tries to escape through this. And then what does it do? It goes that way, but it finds a lot of thermal insulation. So it tries to go up, but it finds thermal insulation. Okay, but this is what the heat tries to do to escape from inside. Okay, so it doesn't go this way because there's a lot of thermal insulation. It doesn't go this way. It goes through the corner. Okay, with these flux vectors, I think it's pretty obvious what's happening here. And it's even better if we use display options and we use color flux magnitude, this one. It can take up several minutes. Okay, so let's click yes and click OK. Cool. Okay, so here we see what we saw with the heat flux with the arrows. Okay, but here we see the colors. So there, the weakest point is always in this diagonal line. So this is where we are losing a lot of heat. And probably if we had more thermal insulation here at the top of this wall, this color would be more purple or less blue. We can always display show color legend. Yeah, so that helps. And show polygon outlines over color infrared. So click here, select this, and let's do it again. Okay, so here you see the profile of the materials. Okay, so we know that the weakest point is the slab and the parapet going up. So if we had more thermal insulation here, that would work better. And this is the BTU hour feet square. So this is the heat that we are losing. This is 0, so we are not losing any heat here. So if it's purple, so this color, it's quite good because, and when we are getting closer to the red color, so the red is always the weakest point, but we can quantify that. So we can get to know how much energy we are losing. So it's not just colors. Oh, it's beautiful. No, we can say, okay, so we are losing 10.5 BTU hour per feet square here. So we can do that. Okay, so what's next? I'm not posting an assignment now, but on Wednesday, I'm going to post another assignment that will be due next Monday. And then you have to work with this, okay? So you have to figure out how to do this with Revit. So first, of course, you have to submit today's assignment. So I just need 2 loads report, one with triple glazing and the other one with double glazing. One load report without passive house standards and the other one with passive house standards, whatever. But I need a second load report that it's better than the first one. So that's the first goal. Second, you have to work with this, and you have to work with your Revit file. And at the end, we need to work with this. We need a parapet, and you need to figure out how to define all these layers so that in this section, I see that you know how to solve that detail. And finally, we will have to do this with THERM. Don't get frustrated if your computer stops working when you are using THERM. It happens. 1 out of 3 times, you will have to close THERM, and probably you will have to restart your computer. Okay, so don't think that that only happens to you. No, it happens to everybody using THERM. So it's like a miracle. We have done this, and at the first attempt, it was correct. It had never happened to me. So it always happens that there's an error, you have to restart everything, and then you have to start from scratch with the THERM detail. And make sure that you save as, this is not a template, this is ARCH360 Parapet detail 1, because there will be different. Okay. So the idea is that we will select good details, and then we will study the THERM file to see how the weakest point affects the thermal performance of that detail. Okay, so this is what we would do next. probably on Wednesday, I will show you how to do this again. So we will have to do that detail in Revit with the floor here, and then we will work with THERM to model that detail. Okay, so by next Monday, you will have to do this in Revit, the parapet and this floor to wall transition. And then in THERM, we need two details. We need the parapet, and then we need that one. So if you are able to do this by next week, it would be amazing. And there is nothing you can't do when it comes to Revit details and THERM analysis of thermal breaches. Okay, so what is the goal? The goal is to reduce this thermal breach. And by looking at this, we understand that this is the weakest point, and I don't know, we have to figure out how to do that, okay? Because this is not the best detail possible because we have a lot of heat losses here in this reddish and green colors. Any questions?
Nope.
Great. Okay, tomorrow I would like to invite you because what is, do you want floors too? Nash, I want floors next week. Okay, so on Wednesday, I'll show you how to do this with Revit and THERM. And next week, you will have to submit the Revit file with all these details and the THERM file with this and that. But for today's assignment, I just wanted what I showed you at the beginning. Okay, so the spaces, the false ceiling, the materials, the roof are 80, the walls are 50 or above. But you don't have to submit these details this week. That will be due on Monday, next Monday.